Hello students, welcome to another session of this Laplace transform. In this session, we will be doing some basic examples, basic problems which can help you in the next classes. So here are some basic problems for finding Laplace transform. Okay, so if you're asked, find Laplace transform of 3t plus 2 whole square plus 5 power t, then how to do it? Okay, so first you need to expand it, otherwise it's going to be tough one. So better you take f of t is equal to 3t plus 2 whole square plus 5 power t. Expand it, a plus b whole square, that is a square, as you all know. A plus b whole square is a square plus 2ab plus b square. So a square means 3t square, that is 9t square will get, plus 2 times this into this, 2 into 2 4, 4 3 is a 12t, plus square of 2 is 4, plus 5 power. And one thing to be noted, we know the Laplace transform of e power at. Okay, so you know Laplace transform of e power at is 1 by s minus a, but we have here a power t, like 5 power t. Okay, so you need to convert it. So 9t square plus 12t plus 4 plus this 5 power t can be written as e power of t log 5. I will explain why it is so. Okay, so e power t log 5 is nothing but 5 power t. Why it is? Because see here, e power log x can be written as x. Okay, so in the same fashion, suppose e power of log 5 power t is there, then you can write it as 5 power t. So this is nothing but 5 log of m power n is n log m. So you can write it as e power of t log 5 is equal to 5 power t. So note down this. So this is useful. So whenever you get a power x form, like a power t form, that can be written in this form, e power t log 5. Okay, this is your f of t. Now apply Laplace transform on both sides. So therefore L of f of t is equal to L of f of t is 9 into Laplace transform of t square. I mentioned earlier Laplace transform of t power n is Laplace transform of t power n is n factorial by s power n plus 1. Okay, so using that, you have to write it L of f of t is equal to 9 into 2 factorial by s cube plus 12 into Laplace transform of t power is 1, so you can write 1 factorial by s square. Laplace transform of any constant by s, and Laplace transform of e power at is 1 by s minus a. So 1 by s minus log phi. Okay. So better you remember this thing. Better you make a note of this. L of a power t can be written as 1 by s minus log a. Whenever you will get log of, that is Laplace of a power t form, so immediately you can keep it as 1 by s minus log a. For example, Laplace of a power, that is Laplace of 3 power t means you can immediately write 1 by s minus log 3. Laplace of 2 power t means 1 by s minus log 2. So let's have few more on this. Find Laplace transform of Laplace transform of, it is sine square 2t plus 1 and even cos square. You can do cos square 3t plus 2. Okay. So I had given in the last class how we can find Laplace of sine square and cos square. Same procedure you have to follow. Okay. So let f of t is equal to, let us call f of t is equal to sine square 2t plus 1. Okay, this sine square has to be converted as sum. I had given sine square theta is, how will you write? You can remember this. Sine square theta can be written 1 by 2 1 minus cos 2 theta. I had given in the last class. The same format, you can write it as 1 minus cos of double of this 2 into 2t plus 1. Okay. Which is equals to 1 by 2 1 minus cos of 4t plus 2. Now you need to convert this into cos A cos B minus sin A sin B form, because we know Laplace of cos AT. So I can write it as 1 minus cos A plus B is cos A cos B, that is cos 4t into cos 2 minus sin A sin B. Let me write this. Cos of A plus B is cos A cos B minus sin A sin B. Okay. So which is equals to 1 by 2 1 minus cos of 4t into cos 2 is constant plus sin of 4t into sin 2 is constant. Okay. Now apply Laplace transform. Apply Laplace transform on both sides. What will get? L of f of t is equals to 1 by 2 as it is constant. Laplace of 1 is 1 by s. Laplace of cos 4t is s by s square plus a square. A square is 4 here, that is 4 square. Into this cos 2 is constant. Similarly, Laplace of sine is a by, that is a is 4, s square plus 4 square into sine 2 as it is. So this is your required result. Now here, sometimes you will get Laplace transform of a function which is given in two subintervals. Find Laplace transform of f of t is equal to, suppose if you are given function in this form, f of t is equal to, so it is e power t if your t is, if your t is between 0 and 1, and it is 0 if t is greater than 1. Okay, suppose if you are given function like this, then how you can find Laplace transform? Very simple, you have to use your basic definition. What is actually L of f of t? By the definition, L of f of t is 0 to infinity e power minus st into f of t dt. This is your basic definition of Laplace transform. Okay, now you have to use the property of integral. You can split this definite integral into sum of integrals. So 0 to infinity, look here, you are given in two subintervals, 0 to 1 and t greater than 1. That means you have to split this. I can write this as 0 to 1 as a one integral, and next part is 1 to infinity, as you all have studied in PUC, how a definite integral can be split. Okay, so for your understanding, I can write integration a to c can be written as a to b, b to c. Okay, so same property is used. 0 to infinity can be written as 0 to 1, 1 to infinity. So respective function you have to substitute. Okay, when t is between 0 and 1, your f of t is given to be e power t. And when t is greater than 1, means when t is in the interval 1 to infinity, f of t is 0. So I can straightforward write this function as 0, or this term as second term as 0. Okay. Now there are two e powers inside the integral. By the law of indices, I can write it as e power minus st plus 1 dt. Plus 1, not plus 1, it is plus t dt. Now take e power minus s plus 1 t common dt. Here it is 1. Okay. Now as we know that e power at is integration is e power at by a. So it is minus s plus 1 t by minus s plus 1 0 to 1. Remember this. Integration of e power at is with respect to t is e power at by e. Okay. So here a stands for minus s plus 1. Now substitute the upper limit wherever t put 1, e power minus s plus 1. If you put t as 1, it remains as it is. If you put 0 here, e power 0 divided by 1 minus s you can write, or s minus, no problem. So your result is e power 1 minus s minus 1 by 1 minus s. E power 0 is 1, so 1 minus s I write. So this is your L of f of t. Okay, whenever the function is given in the 2 subintervals or 3 subintervals like this. Let's have one more. Find Laplace transform of f of t is equal to it is sine 2t if t is between 0 and pi, and it is 0 if t is greater than pi. So again, by the definition, L of f of t is 0 to infinity e power minus st into f of t dt. This is equals to, you have to split it, 0 to e power, you have to split according to the given interval, 0 to pi and pi to infinity. Okay, you can split this interval 0 to infinity as 0 to pi and pi to infinity. Okay, now respective function you have to put. Zero to pi e power minus st. Okay, f of t in this interval, it is given as sine 2t, and in this interval ft is 0, so I can write it as 0. Okay, when t is between greater than pi, so f of t is 0, so this term becomes 0. Okay, now see here, you need to integrate it by the formula that I was provided earlier. So remember this integration e power 18 into sine bt had given already. Integration e power 18 into sine bt is e power 80 by a square plus b square into a sine bt minus b cos bt. So remember this. Here a means minus s, b means 2. So I can write it as e power minus s t by a square plus b square, means s square plus 2 square, into minus s into sine 2t minus 2 into cos 2t. Okay, because here a stands for minus s and your b stands for 2. Okay, and the limits 0 to pi. Okay, now substitute the limits. If we substitute pi, e power minus s pi or pi s by s square plus 2 square is 4, you can write, minus s. If you put sine t as a pi, sine 2 pi it becomes. So sine 2 pi is 0. Okay, better I write, and next I will carry this. Sine 2 pi minus 2 cos 2 pi minus, if you substitute lower limit, e power 0. If you put t as 0, e power 0 by s square plus 4. Sine 0 is 0, so first term is 0, minus 2 into cos 0 is 1, so I can write 2 only. Remember, sine 0 is 0, cos 0 is 1. Okay. E power minus pi s by s square plus 4 minus s into sine 2 pi is 0. The value of sine 2 pi is 0 and the value of cos 2 pi is 1. So it is, yes, this term becomes 0. So first term becomes 0, minus 2 you will get. E power 0 is 1 by s square plus 4, and minus into minus plus 2 you will get. You can write plus 2. Okay, so finally you can write s square plus 4 is common in the denominator and 2 in the numerator. 2 minus 2 e power minus pi s. Okay. So this is your Laplace transform of f of t. So whenever you are given in the split form, you have to do like this. So let me do one more. Suppose find Laplace transform of f of t equals to, it is t 0 is less than t is less than 4, and it is 5 if t is greater than 4. So as usual, L of f of t can be written as integration 0 to infinity e power minus st into f of t dt. This is your basic definition of Laplace transform. Now you have to split this 0 to infinity into 0 to 4 and 4 to infinity. So 0 to 4 e power minus st into f of t dt plus 4 to infinity e power minus st into f of t dt. Okay. Now substitute f of t in this interval. When t is between 0 and 4, f of t is t. So 0 to t, 0 to 4, it is f of t is t. I can write t into e power minus st. Between 4 to infinity, it is 5. So 5 into e power minus st. Okay. Now you need to apply by parts. So this is your u, this is your v. So here you need to apply by parts. So as you all know, so first function integration of second integration of e power minus st is e power minus st by minus s. Okay, next integration of e power minus st by minus s, that is integration of second into derivative of first. Derivative of t is 1 into dt. And the limits here, the limits 0 to 4 and 0 to 4 plus phi in constant as it is, and integration of e power minus st is e power minus st by minus s, and the limits 4 to infinity. Remember this. You must be good at integration, otherwise useless. Now substitute t as 4. If you put 4 here, you will get 4 e power minus 4s by minus s. And if you put t as 0, it becomes 0. Minus into minus plus 1 by s, and integration of e power minus st is e power minus st by minus s. 0 to 4. Okay, it can be done in one line by Bernoulli's rule. So I will be telling it later. So minus 5 by s, substitute the limits. E power minus infinity, it becomes e power minus infinity is 0 minus e power minus 4s. Okay, so you can put it in the simplest form. I can write minus e power minus 4s by s minus 1 by s square I can write, and substitute e power 4 as t as 4, it's a minus 4s. Next e power 0 is 1 minus minus plus 5 e power minus 4s by s. Now look at these two terms, they are same. This is 4 times and this is 5. It is minus 4 times, this is 5 times. Adding these two will get 1. Okay, e power minus 4s by s minus 4 plus 5 is 1, you will get minus 1 by s square into e power minus 4s minus 1. So this is how you can find the Laplace transform of the function defined in 2 or more sub intervals. So in the next part we will be doing properties of Laplace transform. So keep watching and do subscribe to the channel, and if you like, don't forget to press bell button. Okay.